Hello, everyone. My name is Eric Farrell. I'm the product specialist at Milestone for Digestion. Today, I'll be taking you through the application of SRC digestion single reaction chamber technology to consumer product applications. First, we want to go over what causes the most errors in chemical analysis. So this is very important. It shouldn't surprise you that it's going to be sample preparation and human error. Kind of want to start with this slide from the beginning because it's very important to understand that really it's your sample prep technique that's going to help ensure that you're getting quality analytical data. And human error is a part of that in the sample preparation step. There is a way to automate this process, which you're going to learn about in a little bit, to partially automate some of the sample prep step. But really is sample preparation and human error, things that we can control to give us what causes most errors in chemical analysis. Now, most modern analytical equipment will give ICP-OES, ICP-MS, will give answers in a few minutes or seconds. However, it's been seen that the sample prep technique itself is actually the bottleneck, not the analysis, because the analysis can go fast, but the sample prep technique can take, if you're using a hot block or open vessel, it could take multiple hours, or it could take an hour even with the regular types of closed vessel systems, such as a rotor-based system or ultrawave. So heavy metals in consumer products is something we have to test for because these are things that are used. Of course, we all know that heavy metals are toxic to human health, such as lead, arsenic, cadmium, mercury, nickel, chromium. Many other metals are also tested for, but they're found in a variety of consumer products, which are used by people every day. Cosmetics and personal care products, plastic and metal toys, think of children putting things in their mouth, textiles, leather, and packaging. These are all things that consumers use that you're either putting on yourself or you're consuming, or even putting in your mouth. For example, a little child, you want to make sure that any toys or consumer products are free of these heavy metals. And there is a standard that's out there for testing of heavy metals in consumer products. It's called ISO 21392, which is measurement of traces of heavy metals in cosmetic finished products using ICP-MS. This is a pretty general method, lacking other official methods. This also may be a good method to use for other consumer products as well. I'm going to go into more detail what this is later in the presentation. So when we talk about sample preparation techniques, what we're talking about are typically hot block systems or open vessels, as well as microwave systems, which are either traditional rotor-based systems or SRC technology. Open vessel systems are very good because they're a low capital expense and you're only limited by the amount of fume hood space for your throughput. However, they do have some inherent limitations to the technique. You're working at atmospheric pressure, so it means that you cannot exceed the boiling points of your acids. This means on certain occasions you may have to use sulfuric acid if you want to exceed 120 degrees, for example, if you're using nitric acid only. So having to use other dirtier acids to raise your temperature. But using some of those, like nitric, for example, or nitric and HCl, with an open vessel system can take a long time, multiple hours, as you see, for example, EPA 3050, in this case, takes about 3 hours. Also, it's labor intensive because you have to babysit the system. You have to stand in front of it, make sure it doesn't go dry. Uses a lot of acid and high reagent blanks because you're constantly adding acid and you're open to the environment. And also you can have the loss of volatile elements. So what is it that closed vessel microwave digestion is able to do? It's going to give you higher speed and productivity. Because you can go to higher temperatures, you can digest faster. So something that may have taken multiple hours on a hot block could take an hour or less with a traditional closed vessel system. Digestion quality is going to be higher because you can work at higher temperatures and we can accommodate higher pressures. Being in a closed vessel, you can go past the boiling points of your reagents. Also, microwave systems are very safe. There have been tremendous strides in the safety of microwaves compared to earlier versions. Earlier versions used to be simple time and power, and they didn't have the safety features we have now. Think of our rotor-based system now, such as our ethos up on the left over there on the right side of your screen. We have a pressure responsive self-resealing door, easy temp technology to control the temperature, and vent and reseal technology to control the pressure inside the vessels. The systems are very easy to use because we have built-in applications right in the terminal for both our SRC and our rotor-based systems. Simply go into the terminal and load your programs. Also very easy to handle, especially with our ultrawave. And you also have full control of the temperature, and pressure is moderated with our vent and reseal technology. So whichever system that you choose is really going to depend on your application and the needs of your laboratory. So it's going to be your, for application, it's going to be your, if you get with a rotor-based system, we have 3 different types of rotors at Milestone. So depending if you were doing that, going the rotor-based route, we would need to know sample weight, sample type, and what type of analysis you're doing, ICP OES or ICP MS. So we get a good idea of the weight that we're going to need to use. For ICP OES, you may need a slightly higher mass if you have low detection limits in your samples. And also it needs to be something that's easy to use in your laboratory, and it's also going to help meet your productivity needs now and in the future. So when we talk about application requirements for consumer products, really, what are the samples like and how do they behave in the microwave? Most samples are highly reactive, and because of the high organic content. This can be waxes, vegetable oils, alcohol-based products, and plastics. Some of these samples, even plastics, can contain some modifiers such as silicates, or metals can contain alloys in their samples with a heterogeneous metal composition. So you have a wide variety, organic and organic with some inorganic, typically is what you're going to see for consumer products. Now, what are the challenges you have to overcome in order to work with these types of samples? Well, you need a system that's able to digest over 200 degrees Celsius, something that's going to give you high pressure capabilities because these samples are highly reactive and prone to exothermic reactions. One of the things I'd mentioned earlier is sample mass impacts the pressure of the vessel. So higher sample mass you're going to have of an organic sample, the higher the pressure is going to be inside the vessel or inside the reaction chamber if you're doing SRC. Chemical compatibility with HCl, nitric, and HF, you want to make sure that you are able to use these different reagents because these are typically what's used, especially nitric and HCl, HF on occasion. Now, what are the workflow challenges that you have to consider also, not only the application challenges? So you have to be able to handle different matrices. System needs to be able to digest a wide variety of different samples that are going to be coming across your lab bench. Also, you want to make sure that you're improving your productivity and efficiency in your laboratory. Handling time and processing time can impact your lab productivity. So you want to think of what goes into your workflow as far as preparing your samples in that sample prep step. And also a better turnaround time because working with closed vessels, we can have digestion programs that are much faster than an open vessel system. So rotor-based systems are great. They've been the workhorse of laboratories for many years, though they do have some inherent limitations to the technology. All the vessels are polymer-based, so you can only go so hot for so long, typically 30 to 60 minutes at high temperature. Each vessel is at its own temperature and pressure, which means you have to run samples of similar reactivities together. Vessel handling can require multiple steps. It requires assembly, disassembly, and also manual venting of the vessels to release the pressure at the end. And then vessel liners can require intensive cleaning depending on your analyte levels. So how is it we're able to optimize the digestion step? We do that with the introduction of SRC technology with our UltraWave 3. Our UltraWave 3 is going to provide higher temperature and pressure, elevated digestion performance, higher temperature and pressure than you can do with traditional rotor-based microwaves, giving you higher digestion quality. It's compatible with any acid chemistry. You can use nitric, HCl, HF, all with vials with loose fitting caps. You do have the ability, which you're going to learn, to run mixed batch samples. So you can run organics and inorganics or any types of organics, even with metals and metal alloys, together in one single run. So how exactly does SRC technology work? In case you haven't seen it on one of the previous workshops, I'm going to go through this with you now so you have a good idea of how the technology works. This is very important. So instead of having individual reaction vessels that are processed in batches, we have a 1 liter stainless steel reaction chamber. Inside there, we have vials. We take vials, we weigh out our sample into the vials, add our acid, place a loose fitting cap on top, and then suspend it from the top of the UltraWave system. We then take it and lower it down into a base load of acidified water. This base load of acidified water ensures all of my samples are at the same temperature and pressure conditions, which allows me to run full mixed batch samples. So I can run that metal alloy together with a plastic if I wanted to. Next thing we're going to do is pre-pressurize with 40 bar of nitrogen, which raises the boiling points of all the reagents and prevents cross-contamination between the samples. It's this pre-pressurization that allows us to use vials with loose fitting caps. Next thing we're going to do is we're going to do a standard ramp to temperature and hold the temperature like you would with any microwave program. So in this example, we're going up to 250 Celsius and we're going to hold there. Once we get to 250 Celsius, this is where the dissolution of our samples is going to start, right over here. So at your hold temperature, this is going to be similar to what you would do in a rotor-based system where you have your hold time. Once your sample dissolution is completed, instead of having air cool it down, you're going to use a powerful external chiller, which is going to circulate cold water around the outside of the reaction chamber. Going to cool it down to 80 degrees Celsius, which is 20 degrees below the boiling point of water. Then we slowly depressurize the system at a rate of about 8 bar per minute. This takes the place of you having to manually depressurize your vessels under a fume hood and letting out the pressure. Once the system's completely depressurized, it's going to allow you to open up the reaction chamber only once it's depressurized. Take out your samples, dilute them up to final volume, and go ahead and run them on your ICP OES or your ICP MS. So the Ultrawave is able to handle very high temperatures, up to 300 C, 199 bar, 280 degrees C operating temperature. So that's how hot you can run at its maximum. This is going to be very helpful for cosmetics and plastic toys. Cosmetics, you're running anywhere from 200 to 240 degrees Celsius. Sample mass about 0.2 to 0.5 grams. Plastic toys, some plastics are a bit difficult to digest. So we're working with 0.2 to 0.5 grams. Typically, we may even go as high as 250 Celsius, which is higher than what you can do with a rotor-based system. The Ultrawave can go up to a maximum operating temperature of 280 Celsius, whereas rotor-based systems are limited to about 240 Celsius for about 30 to 60 minutes of temperature. So the Ultrawave's higher temperature capability can be very helpful, especially when working with certain plastics that are very stubborn to break down. The Ultrawave is going to give you the highest temperature and pressure working range. It's going to be suitable for any reactivity of sample, high reactivity, low reactivity samples, and of course, it's compatible with any type of acid chemistry that you put onto it, as far as nitric, HCl, et cetera. So next thing we have is what is the workflow like when working with a rotor-based system versus SRC when it comes to mixed batches? So when you have a mixed batch with a rotor-based system, you need to run your samples of different reactivities separately. For example, in this case, lipstick, plastic toys, and leather need to be run separate because we're controlling the microwave power to the entire cavity, and each individual reaction vessel is its own digestion taking place separate from one another within the microwave cavity. However, with the Ultrawave, because all samples are at the same temperature and pressure conditions, which we can ensure, that means we can run plastic toys, lipstick, and leather all together in one single run. So we have different racks that are available for the Ultrawave. Vials are available in PTFE, TFM, quartz, or disposable glass, compatible with any acid chemistry. We have a 7-position rack, which are 40 ml vials, 20-position rack, which are 15 ml vials, and we have a 27 rack with 8 ml vials and 40-position rack with 4.5 ml vials, 4.5 milliliter volume vials. For our consumer products testing, we typically would suggest our 20-position rack, which is going to give you the best compromise between sample mass capacity and acid volume. We have them available in disposable glass, quartz, and Teflon. If you're using HF, you would want to use Teflon for lower detection limits. Quartz is going to be very helpful too, especially with oily samples. If you have a polymer that floats on top of the acid, using a quartz vial is going to be ideal. The system overall requires less operator time, as you can see from the video previously, because we use vials with loose fitting caps. It's going to give you less handling time compared to rotor-based systems, which require assembly, disassembly, and venting of the vessels. The Ultrawave is able to, does not require assembly or disassembly of the vials because we put the loose fitting cap on. We have that 40 bar pre-pressurization. And we also have automatic venting of all the vials in the reaction chamber at the end of the digestion run. If you are able to, we do have disposable glass vials. Disposable glass vials can be very helpful because you don't have to clean them. You can simply throw them in the garbage when you're done. However, if you're looking at sodium, silicon, boron, potassium, aluminum, calcium, or magnesium, anywhere in the ppb range, you want to evaluate your use of disposable glass because it might not be a suitable option. In those cases, you may want to look at using quartz or Teflon. Now let's go into the ISO standard I mentioned earlier, 21392. So this ISO standard is designed for the determination of chromium, cobalt, nickel, arsenic, cadmium, antimony, and lead in cosmetics, in cosmetic products, and consumer products. Sample preparation requires a closed vessel system, whether it's a rotor-based or SRC technology. Assembly of the vessels, the assembled vessels must be able to withstand 200 C and 40 bar of pressure, and analysis is going to be done by ICP-MS. Now, when we take a look at this for the use of cosmetics and consumer, well, this is mostly for cosmetics, but for a lack of other methods for consumer products, this is something that could also be used too. Most samples are going to be first dried to remove traces of solvents, because things like nail polish and certain liquids, solvents are very reactive and prone to exothermic reactions. So we try and dry those off if we can, as per the ISO standard. Sample mass we're going to use is either 200 milligrams or 400 milligrams. 200 milligrams for dry samples, 400 milligrams for samples with high water content, such as lotions, cleansers, or micellar water. Reagents you're going to use, 5 mils of nitric, 1 mil of HCl, a mil of water. The purpose of the 1 mil of water is to help quell any exothermic reactions which may occur. The one nice thing about the Ultrawave is it does work well with water, because we can go to higher temperatures and pressures than you can with rotor-based systems. However, for this method, HF is not required, because it's been found that many of the heavy metals that are not released from solid particles that are remaining really do not impact the level of metal exposure to the consumer. So for those reasons, HF is not required for this type of digestion. But you can still, if you wanted to use HF to break those down, you could, but this method does not call for that. So by controlling the digestion temperature, we control the digestion reaction of the sample. Higher temperatures lead to faster digestion. Digestion temperatures typically we're working with are up to 200 C or maybe even hotter. 200 C for the ISO standard, greater than 200 C for most other applications. And the ramp time you're going to run is going to be dependent on the reactivity of the samples. For example, if we were running something that's very reactive, such as nail polishes or perfumes, dyes, or lipsticks, we use a reactive program, which is a slow ramp up to temperature and a single hold to temperature. So for more reactive samples, it's important to extend the ramp time so you don't have an exothermic reaction pop up. Typically, a standard ramp is a single ramp to temperature and a hold to temperature. But when working with more reactive samples, you want to have a stepped program, kind of like you see here, which will hold at certain temperatures right before exothermic reactions occur. So I'd like to share a case study with you of a global leader in the cosmetics industry who's a Milestone user. Heavy metals analysis for them is mandatory for regulatory and consumer safety purposes. They identified the Ultrawave as a solution for them because they have a wide variety of different samples that come across their lab bench, and they also work with difficult to digest samples as well. They've implemented 11 Ultrawaves and 4 trace cleans in their systems in the US laboratories, which are shared between R&D, raw materials, trace metals lab, and their production support. They're a user of our Ultrawave 2 as well as their trace clean. For the Ultrawave 2, they're working with samples such as zinc oxide, titanium dioxide, and raw ingredients digested in nitric HCl and HF. SRC technology provides them much higher safety and convenience compared to other sample prep techniques. Safety because we have the external chiller, there's no vessel venting, and there's less handling of acids, less handling in this overall sample prep workflow. Plus, we have multiple safety guards such as temperature and pressure limitations that are built into the system. As far as streamlined workflow, you can simply load your samples into the Ultrawave and just hit the start button, and then you go ahead and run. And there's no need for vessel assembly, disassembly, or even vessel venting at the end. That's done all automatically. As far as use of the trace clean, the reason that they purchased a trace clean was to work is because they want to eliminate the need of acid baths and acid soaks, nor do they want to have to clean their vessels inside their microwave. They're using quartz and mainly Teflon vessels, so these need to be cleaned in the trace clean. And it's better and more efficient to do it in that offline manner than do it in your microwave. I'd like to share some examples of some experience we have with some consumer product samples that we've run. So this client sent 2 sunscreen samples for digestion and analysis, and the goal was to find a method that would work for that. So what we did here was we did a 1/4 gram of sample using 4 mils of nitric, 1 mil of HCl, and 3 mils of fluoroboric using the Ultrawave. With the Ultrawave, we used a reactive program to 230 Celsius with a 15-minute hold there, which resulted in a complete digestion. Some of the components in sunscreens can be a bit reactive, so for that reason, we use a reactive program on our Ultrawave to make sure that we're able to achieve complete digestion of the sample in a safe manner. Next is antiperspirant. Antiperspirants are a good example of challenging matrices because they have it's a heterogeneous sample. It has a lot of different components to it, such as siloxanes, organic modifiers, and some antiperspirants still even have aluminum in them, or aluminum oxide. This was digested on the ultrawave using 0.5 gram with 5 mils of nitric and 1 mil of HF. With this digestion, we went to 250 Celsius and held there for 10 minutes. This is hotter than we can go with a rotor-based system. And what we did was, when we were all done with the digestion, we complexed with boric acid to eliminate any insoluble fluorides, calcium or magnesium that may have formed, and to neutralize any excess HF that was left over. Now, just to kind of summarize what we went over, so SRC technology does provide enhanced safety over rotor-based microwaves, as you had seen earlier, especially during the case study. Rotor-based systems do not provide the same productivity compared to SRC technology, because SRC technology is going to give you streamlined workflow, no vessel assembly or disassembly, and nor do you have to manually vent the vessels at the end. While some samples are easier to digest, some samples require higher temperature and more complicated acid mixtures for complete digestion. So you can see that example where I had to use fluoroboric acid or HF in here. Also, when working with organic samples, we have superior control of the reaction because we utilize an easy temp temperature sensor, contactless temperature sensor within the ultrawave, which is monitoring the temperature of all the samples, and all the samples are immersed in the baseload, which is going to give us superior control over exothermic reactions. One of the last things I'd like to show you is taking a look at your total sample prep workflow in your laboratory. So going from sample homogenization and sampling your sample all the way to getting your elemental analysis, there's a lot of different steps you have to take to get there. You want to take a look at your sample prep workflow from the 30,000-foot view and see, are you doing everything in your laboratory and your process and your workflow that's going to make sure you're as efficient as possible, minimizing any downtime, minimizing human error, and optimizing the labor time of your users. So for example, are you using the appropriate acids? Are you making sure your reagent handling is solid? You can also look at other automated options as well, such as our easy fill. We have vessel cleaning, microwave digestion, and also vessel cleaning, such as our trace clean acid steam cleaning system. So we do have a lot of solutions for the sample prep workflow. You don't want to just take a look at this and make sure you're doing this as efficiently as possible. And Milestone does have solutions for a lot of these aspects of the sample prep workflow. So that's what I have for today for consumer products. I thank you very much for your time. And with that, I'll pass it back over to the moderator.